Good morning all, and today I'm looking at this, which is an RFID tag or card reader writer, and it uses the RC522 chip from NXP. Now with this typically you get a card and also a single tag, keyring type tag, and then also separately I bought a set of 5 tags so that I could take a look at them, take them apart and see how they work. So this is the item on eBay. It's described as a MyFair RC522 card read antenna RF module RFID reader IC card proximity module. They're just $3.38 for the kit, which includes the reader writer and the keyring tag and the card. Free shipping, and this one came from Alice 110 1983. Now Alice is also selling 5 tags for $1.50, or you can get 100 smart cards for $25, 5 smart cards for $3, and so on. So they are very cheap, so I've got no hesitation in taking one apart. In fact, you can probably see that I've had this one apart before. So let's see if I can get the cover off. Not easily, it would seem. Okay, the cover's off. This is the little insert actually, and inside you can see there's a chip with effectively 2 pins. They're kind of metal wings, and there's a coil of wire. Let's get a close-up of that. Magnifying glass. So there's the chip. Doesn't appear to have any markings on it, and the coil of wire is quite neatly wound. I'm not sure how many turns that's got. What do we reckon? 10 or 20 or something like that. Now the card is credit card style. It's extremely thin. Hard to believe there's a coil in here, but you can find it if you use a torch. So there's the chip, and you can see the wires coming out to the coil of wire which runs around the outside, but the chip's embedded in the card just there. So let's wire this up. I've put 7 wires from the RFID card into this, which is an Arduino Pro Mini. Now because this is 3.3 volts, I've decided to go for a 3.3 volt Pro Mini. That's my blue tack, but they're generally speaking marked on the back. There are little pads here indicating the voltage and the frequency. This is a 3.3 volt 8 meg. I've also got one of my USB to serial adapters here. This is actually an FTDI one. I probably could have used a CH340 switch to 3.3 volts, but I thought I'd go for an FTDI today just for the fun of it. Now Google search for RC522 gives you the datasheet of the chip. This is at nxp.com, so we'll certainly be looking at that. Arduino Playground, so people have been playing with these reader writers, some images there. An Instructables article on using it for door unlock, which is the general usage of this kind of system. It's for access control. But here we've got a library, and this is Miguel Balboa RFID. Now this is the library that I chose to use to get this thing up and running. So if we click through to that, we get to GitHub, and then on here in the README, which is immediately below the file or directory listing here, there's useful stuff like a pin layout, so you can see how to connect your MFRC522 to an Uno or a Mega or a Nano. The Uno and the Nano pins are very similar for the Pro Mini. They've also got the Leonardo there. So you can see here on the reader writer, I'm using 3.3 volts, that's VCC or VDD. Reset, which goes to one of the pins on the Arduino, and ground. And we've got a full SPI implementation here. It's labeled SDA, SCK, MOSI and MISO, but SPI generally uses SS rather than SDA. Let's have a look at Wikipedia on that. So here's Wikipedia on the serial peripheral interface bus, and the diagram over here shows the signals as S-clock, MOSI, MISO and SS with a bar over it, so it's active low. That's the master, and the slave, yes, the names are the same. So this SS is the equivalent of the SDA on the RFID card. And in fact, in Miguel's notes under this connection table, it does say the SDA pin might be labelled SS on some older RC522 boards. Well, it's labelled SDA on this one. So I've wired the RC522 to the Arduino Pro Mini as per Miguel's connection table. I've connected the Pro Mini to the USB to serial converter using VCC ground, TX, RX and DTR for reset. And my FTDI board is connected through to my PC's USB. Now I'm going to stick this to my monitor because I want to watch what comes back on the serial monitor in Arduino IDE, so there's not much point this being down on the bench. So I've installed Miguel's RFID library into my Arduino. Now this is a brand new sketch, today's date. So if I go File, Examples, and then come all the way down to the bottom of my monitor, there's RFID, and here are some of the examples that Miguel has provided. Now I'm going to start with this one, Dump Info, because it's, so that opens there. It's kind of the one that gives the most information. Now you can see in this Dump Info sketch, once again we've got the connection information here for SS, otherwise called SDA, Mozzie, Mizzo and Clock, also Reset, and then there's the sketch itself. Now it's not a very long sketch, in fact that's it. I've scrolled right to the bottom. I'll just come out a bit there. It's a very short sketch, but everything appears to be done in this function, which is the dump to serial. And you can go and look at dump to serial on GitHub, and it's quite complicated. There's a lot going on in there. But let's compile this dump to serial. This dump info sketch. I've just pressed the compile button. You can see the red and green lights there are flashing to indicate that the data is going down to the Pro Mini. So that should be in and running. And next I need to click up here to open a serial monitor. And then it actually speaks to me and says MFRC522 software version, scan PICC to see the UID, that's the unique ID, type and data blocks. So now I've stuck the reader to my monitor here. So if I put one of these cards, I'll do the card first, over there, you can see that immediately it starts picking up all the data and displaying it on the monitor. So the first thing that this tells me about this card is that it has the unique ID 7E6F3D65. Now that's hexadecimal numbering. It also tells me that it's a MyFair 1 kilobyte card, otherwise known as a MyFair Classic. And then it starts listing out the sectors. Well, there are 16 sectors. It goes from sector 15 down to sector 0. There are 64 blocks. It goes from 63 down to 0. And here's the actual data. These are bytes, so they're hexadecimal digit pairs. There are 16 bytes per block, and there are 4 blocks per sector. Okay, let's try this one that I took apart. See if it reads that. So yeah, once again, here's the second block. Now we've got some problems. It's saying timeout in communication. And in fact, there's another one of these cards. This tag that came with the card as a set with this, also, it reads the UID. You can see the UID scrolling up there, but it won't actually read any data. I'm not quite sure why that is yet. So there is some issue with this tag and the tag that I took apart. But let's try a tag that does work. Let's try this one. And there's the data coming up the screen. Now I'm just going to place this tag in front of the reader, but not long enough for it to dump all the data to see what the effect is. So let's put it on there and then take it off, and it will stop. But the reason I wanted to do that was because I wanted to show that the sector 0 down here, block 0 in fact, this is sector 0 and block 0. You can see that the first 4 bytes are 2371C4A9, and they happen to be the same as the card UID There's then some other stuff in that sector 0, but in the sectors above, it's this repeating pattern. In fact, this one, I think I've done some things to it, so it's slightly different. But you'll see that in the top, is it a sector or a block? I can't remember. But you get this pattern of 6 00s, then this 4-byte code, and then you get 6 FFs. Well, now it's time to go to the data sheet, because none of this makes much sense until you start reading the data on the chip. So I'm going to start here at nxp.com, and in their search box I'm going to type RC522 and just see what comes up there. So here's a page on the NXP website on the MFRC522 chip, and it's worth reading a little bit of the introduction to this. It's a highly integrated reader-writer IC for contactless communication at 13.56 megahertz, and it supports these MyFair cards. But what I really wanted to do was look at the datasheet of one of the actual card chips. Well, here's one. It's got a horrible number, the MF1S50YYXV1 and all that stuff. But it is a MyFair Classic 1K mainstream contactless card, smart card IC, and there is a datasheet. So let's take a look at that. Now, here's the thing on the memory organization of the chip. It says it's a 1024 by 8-bit EEPROM, organized in 16 sectors of 4 blocks. One block contains 16 bytes. Now you can see that in the upper block, block 3 of each sector, we've got 2 keys. Key A spanning 6 bits, then some access bits, 6 bytes, and then key B spanning the upper 6 bytes. Now if I scroll down, you'll see that in sector 0, block 0, we've got this grey bar and it says manufacturer data. And if I go down a little bit further, it says the manufacturer block. This block is programmed and write protected in the production tests. So this first block is actually read-only. And if I go back to my listing on the serial monitor, you can see how in this block 0 we have the UID in these first 4 bytes. We then have this manufacturer data. You can't write to this block here. If I go a little further up, you can see for here, for example, in sector 3, here are 600, so that's key A. And then this FF078069, these are the access bytes. And then the 6 lots of FF is actually key B. So what's all this key A and key B business? Well, let's look at Wikipedia's article on the MyFair Classic. This is the card that you get with these reader-writers. It says the card's fundamentally just a memory storage device. Memory is divided into segments. They are ASIC based and have limited computational power. Thanks to reliability, low cost, etc. They're used for transportation. In other words, like rail systems, stadium ticketing. These are used as access control and tickets for events. So the MyFair Classic 1K offers 1024 bytes of data storage split into 16 sectors. Each sector is protected by 2 different keys called A and B. And this is where the whole business of encryption comes in. The data in these tags is encrypted. So it says here it uses an NXP proprietary security protocol called Crypto1 for authentication and ciphering. And then interestingly down here it says MyFair Classic encryption has been compromised. See below for details. And if you click through the links provided, you'll see this really lengthy document from a university in the Netherlands, I presume it's students, who actually broke the encryption system on the MyFair Classic. It's extremely complicated. It goes on forever and ever and ever. I did read it. It's quite fun. How you would set up your own breaking of this encryption system, I honestly don't know. I didn't understand much of it, to be honest. Now, also supplied in the examples in this RFID library is something called change UID. So we should theoretically be able to change the user ID. Let's compile and install that sketch and have a go at that. Let's see when these lights start to flash. There they go. So once that's in and running, I'll need to put up the serial monitor. Let's wait for that to install. That's just verifying now with the red light. Okay, let's go to serial monitor and try that one out. So this one says, warning, this example overwrites the UID of your UID changeable card. Is this a UID changeable card? Well, it doesn't appear to be because it's just doing a dump there. But if I scroll back up, it says here, card did not respond to OX, that's hexadecimal 40 after halt command. Are you sure it's a UID changeable card? Error, timeout in communication. Activating the UID backdoor failed. And then it just does a UID listing and a memory dump. So what on earth does all that mean? Okay, well I fancy trying this one called read and write. So let's load that one in. Okay, so this one says scan a MyFair Classic PICC to demonstrate read and write. It's going to be using the key for A and B of 6 lots of FF. Beware, data will be written to the PICC. PICC stands for Proximity Integrated Circuit Card. Anyway, let's bring one of the tags up. Right, I have to bring the camera down here. Communicating again using key B, reading data from block 4. Did this actually do it or not? Looks like it did, because in block 4 here, the data is all zeros on this bottom line, and it said it read all those zeros. It then said it was writing data 01, 02, 03, 04, so this is clearly data that was written in. It then said it's checking the result. The number of bytes that match is 16. Success with a smiley face. And here in, what's this, block 4, we've got that data, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it seems to stop at, oh, well then it does FF, B, C, D, E, F. What happened to OA? So this is an interesting device. It kind of works, the library seems to work, the hardware works, it can read the cards and the little keyring tags. There do seem to be sort of quite a lot of problems with certain tags. They either seem to fail, or maybe I've written data to them that has somehow corrupted them in some way. I think the Miguel Balboa library was the right way to go. This certainly seems to be current. It says here that something was authored 8 days ago, and in fact it's actually the examples, so they're being updated. They're quite recent. But this is complicated stuff. The datasheet for this RC522 reader-writer chip is 95 pages long. I mean, it's very complicated in terms of all the registers that are inside this chip. And the encryption system just adds to that complexity. So this was just a fun first look at this RFID reader-writer, the RC522, and all the tags that come with it. It is complicated. There's a lot more work to be done on this if I wanted to actually use it for something. But to be honest, I don't really know what I'd use this for. I mean, you've got the obvious access control, getting in and out of doors and rooms. But I can't really think what I'd use it for much beyond that. Cheerio.